Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 88. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to first start by rewriting my equation down here so I have a little more solving space. So my equation is 8 to the power of x is equal to 88. Now I'm first going to start by taking the log on both sides. So I get log of 8 to the power of x is equal to log of 88. Now, if I have something in the form log of a to the power of b, I can move this exponent b to the front, so this is going to equal b times log a. In this case, I have log 8 to the power of x, and I can move x to the front, so I get x times log 8 is equal to log 88. And the reason this property is so useful is because before, x was an exponent. And for our equation, if x is 1, I get 8. If x is 2, I get 64. And if x is 3, I get 64 times 8, which is 512. And we want to find what value of x results in 88, which is somewhere in between 2 and 3, but we don't know exactly where because it's going to be a decimal. So we can't really find the exact value as x when x is in exponent form. So this is why we can make it into a real term using this property, and now it's much simpler to solve for it. So now I have x times log 8 is equal to log 88. And I want to isolate x because that's what I'm solving for, so I'm going to get rid of this log 8 by dividing both sides by log 8. So now these two cancel out, and I get x is equal to log 88 over log 8. Now log 88, I can rewrite this as log of 8 times 11. So I have log of 8 times 11 over log 8. And now another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So log of 8 times 11 is going to equal log of 8 plus log of 11, and I have this over log of 8. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, which is a simple fraction property. So log 8 plus log 11 over log 8, I can write that as log 8 over log 8 plus log 11 over log 8. Now, log 8 and log 8 cancel out to get 1. So I get 1 plus log 11 over log 8. So now all that's left is to plug in the actual values of log 11 and log 8 and solve. So log 11 is equal to approximately 1.04, and log 8 is equal to approximately 0.90. So I get x is equal to 1 plus 1.04 over 0.90, which is equal to 1 plus 1.16, meaning x is equal to 2.16. So this is my answer. Alright, so in this video, I'm going to be proving to you guys that pi is equal to 3. So as you guys probably already know, pi is an irrational number, meaning it doesn't have a whole number value, and it's actually equal to 3.14159 and on so forth forever. So that's why it's an irrational number. It's the just don't stop going. So in this video, I'm going to be proving to you guys that pi is actually equal to 3 and not the irrational number that we all know it is. So what I'm first going to do is start with the statement x is equal to pi plus 3 over 2. So all I'm doing is I'm giving a value to a variable, which is completely illegal. So now what I'm going to do is multiply both sides by 2. So I get 2 times x is equal to pi plus 3 over 2 times 2. Now, 2 times x is equal to 2x. So I get 2x is equal to, these two 2's cancel out, pi plus 3. So I get 2x is equal to pi plus 3. And now, from here, I'm going to multiply both sides by pi minus 3. So I have pi minus 3 times 2x is equal to pi plus 3 times pi minus 3. Now, pi plus 3 times pi minus 3, I'm going to distribute the pi, so I get pi squared plus 3 pi minus 3 pi, which they just simply cancel out, plus 3 pi minus 3 pi. These two cancel out. And then I have minus 9 at the end. So this is, I can just say this is pi squared minus 9. And for my left-hand side, I can distribute the 2x, so I get 2x pi minus 6x. And now from here, I'm going to add x squared on both sides. So I have x squared plus 2x pi minus 6x is equal to pi squared minus 9 plus x squared. And let me just reorder this real quick. I'm going to write this as x squared minus 6x plus 9. So I'm going to add 9 on both sides. Is equal to x squared minus 2 pi x. So I'm going to subtract 2 pi x on both sides. And at the end, plus pi squared. So I have x squared minus 6x plus 9 is equal to x squared minus 2 pi x plus pi squared. And now, x squared minus 6x plus 9, this factors out into x minus 3 squared. And x squared minus 2 pi x plus pi squared is the same thing as x minus pi squared. So I have x minus 3 squared is equal to x minus pi squared. And now, I want to cancel these two squares, so I'm going to take the square root on both sides. So now the square root of x minus 3 squared is equal to x minus 3. And the square root of x minus pi squared is equal to x minus pi. So I get x minus 3 is equal to x minus pi. So now I'm going to cancel these two x's out by subtracting x on both sides. So now I get negative 3 is equal to negative pi. And now if I multiply both sides by negative 1, I get pi is equal to 3. So there you have it. I just proved that pi is equal to 3. So now, where did I go wrong? Because obviously we know that pi is not equal to 3. So where did I go wrong? Well, I actually went wrong on this step right here, where I said that the square root of x minus 3 squared and the square root of x minus pi squared is equal to x minus 3 and x minus pi respectively. Well, this is actually not true. The square root of x minus 3 squared isn't equal to x minus 3, it's equal to the absolute value of x minus 3. And same goes with the square root of x minus pi squared. It's not equal to x minus pi, it's equal to the absolute value of x minus pi. So the reason this is so important is because now I get x minus 3 is equal to negative x minus pi. Or also negative x minus 3 is equal to positive x minus pi, since we're taking the absolute value of these two. So if we want to solve x minus 3 is equal to negative x minus pi, we're going to have to first distribute the negative sign. So I get x minus 3 is equal to negative x plus pi. So now if I add x on both sides, these two cancel out. So I get 2x is equal to 3 plus pi. And x is equal to 3 plus pi over 2, which, going back, is what we started with. So there you have it. That is something really important to know, that the absolute value is, the square root of a square isn't just the normal version, it's the absolute value of that.